In this tutorial, we're going to learn about some of the fundamental geometries in Grasshopper and look at transformations. We're going to create a looping figure and then use some plane transformations and mirroring relationships to build more complex forms. So I'm going to introduce first some of the basics of Grasshopper. So basically, how we can create simple geometries from points. We're going to look at lines, arches, and then learn about transformations using vectors. So let's begin by creating a point. To create a point, you can go to the Vector tab. Under Point, you can choose Construct Point, and you can just drop it into the canvas. Or you can simply double click on your canvas and type up XYZ, Construct Point. Now, once we have created the point, you can see that it's a virtual object in Rhino, and we cannot select it because this is a parametric object. So we can create a number slider. You can either double click on the canvas, type any number, or you can go to Parameters, Input Number Slider. And the number sliders could be customized. So if you double click on the number slider, you can actually change its interval. For instance, we can set up a range to be up to 10. We can make it floating value with some decimals. We can set it to be even or odd. So I'm going to create a point with a z coordinate, so we can move this point like so. And I'm going to create a second point, and that one, let's move it along the x-axis. So if you look at the coordinate system, you can see that we have a grid, and that grid is constrained by the x and y vectors. X vector is the red axis and y vector is the green axis. We don't see the z, but it's actually a blue axis going up. So we can move this second point. Let's say we want to disconnect this part. We right click, disconnect, and we can disconnect this slider, and we connect it to the x, and I can move it along the x-axis now. So let's say we want to move it 8 units, and then we can create a line. So I want to connect these 2 points into a line, and we cannot see, we can see the line here is actually overlapping with the coordinate system, but we can also do, you can also connect it to both z coordinates of the points, and you can move this line up or down. So I'm going to set it to be at 2 units high, and we have created a straight line. So we're going to start with this line that is parametric. We can actually change its length, and I'm going to create a third point, but this time we're going to use vectors. So let's say that we grab this point and we want to move it along the coordinates, let's say using the XYZ vectors. So because we have this coordinate system, it already sets some vector directions for our transformation. So if I want to move this point, we can actually use the move command, which basically takes in a translation vector and an object. So I can translate this point using a translation vector. By default, the vector is set to 10 in the z direction, but we can also set it in any type of direction. So if you look at the coordinate system on the bottom left, let's say we want to move it in the positive y direction. So I can set a unit y vector, and we can specify some length to this vector. So let's say we want to move it 5 units in the y direction. So this could become the translation of this vector. So we can move it 5 units in this direction. Now these constructions are linearly associated. So if I at any time move these coordinates, you can see that all the subsequent operations are also changing, because this point's location is bounded by the first point, and the second point's transformation is bounded by the end of the line, right? So wherever the line ends, then the object is moved 5 units in the y direction. So we can basically build some of these parametric relationships in a linear fashion. Now, using this point, let's create a second line connecting the translated point and this one, end of the line. Now we have two curves, and both of them are parametrically controlled, so we can control their length. We can also join them into a polyline. So you can type in join, and we can do join here. And if you want to combine two curves, you can hold shift on your keyboard and attach two lines at the same time to join. And look at the output. Now it's a polyline curve. And because these curves are connected, now we can do some filleting operation. So we can double click again, type in fillet the sharp corners of a curve, and this takes in a curve and it takes a radius. So let's say we put in 2. Now that curve is being rounded up. We can also make this a floating value by modifying it, and we can actually change the radius. You can see that it has some limitation because the rounding actually is constrained by the length of the curve. We are also seeing two curves overlapping here. That's because Grasshopper displays all the history of the operations. So at any time you can choose some of these points or geometries and find out where they are and what they're doing. If you want to hide them, then you can select them one by one, right click and disable their preview, or you can select them in a group, go to solution and turn the preview selected off. So that way we can have we can visualize only the filleted curve. The next step is to create an arc in another direction. So that arc, we can actually set it to be going in the vertical direction, let's say. Arcs could be defined by some planes. So we have this filleted curve. We also have this point here, the end point. What I want to do is create an arc that goes loops in the vertical direction. So if you look at the coordinate system, that arc is going to be placed in the YZ plane. So if you look at it from this view, we want to draw it in this fashion here going up. So we want it to be on the YZ plane. So I can set up a YZ plane on that point. Now by default YZ plane comes in like this, but we can place it at any location, at any point to be its center. And for the plane, we want to use this point, but we need two other points. So to create those 2 points, we can use this plane, and we can use point oriented. If you type in point oriented, this is another way of creating point geometries. It's located under vector point. So similar to XYZ, this takes in UV and W parameters, but it takes in a plane as a boundary. So if you attach this plane here, now the UV W parameters will specify the coordinates of the point oriented to that plane. So let's say we specify unit 5 in the Y direction. So I connect it to the V, and you can see that that point is moving along the Y-axis of that construction plane. And the second point we need for the arc is going to be actually somewhere here. Basically, it's going to have the V value of half of this and the U value of the same as well. So I can create a second point, and I want to draw a mathematical relationship between these two. So I can simply divide 3 value by 2 to find the midpoint in the V direction, and I want to use this in the U direction as well. So we are drawing in the positive direction. You can also make these negative values. If you double click here, let's say in any case you want to make it negative, you can also change its coordinate to be in the negative direction. You can change the slider for that. So we have 3 points here. We have the origin point, we have the end point, and a midpoint, and we're ready to create our arc. So if you go to curve primitive, there is arc 3-point option. So this takes in 3 points. Our first point is the origin, the second point will be the midpoint, and the last point will be the end point. So we have created an arc oriented on that plane. So all of these constructions are bounded by other geometries or planes, right? So we are creating points using planes, then we are creating geometries on using those points. So basically, complex geometries are built with simpler geometries. So lines could be built by points, arcs could be built by points as well, and we can use planes to orient points in different directions too. We have the arc and we have the joint curves here. So we have pretty much like a complex shape that we want to create. I'm going to actually hide this plane for now, and we have the joint curve here with the fillet. Let's keep the fillet, and let's join it with the arc so that this becomes a more compound shape. So I'm going to do another join curves here. Join curves, and I put in the rounded polyline and the arc using shift again. So if you look at the output, it says that it didn't actually correctly join the curves because they're coming from different directions. So sometimes you can fix this by right clicking here and doing flatten. So that will maintain kind of a simpler list, and because these geometries are subjected to different operations, sometimes the join may not work, so you might want to add a flatten here. Now we have a simpler, just a single shape. Now one other thing we could do is keep advancing this geometry any way we want. We can maybe move this point in this direction and join it there as well. So let me do that again. So we can move this point. This time we want to move it in the negative y direction. So I can do y, but I want to put in -5 ... 5. That will be a shortcut for setting up a negative interval value slider. I can combine it here. So that could be -5 or something smaller, let's say -2. And we can draw another line here. And this line could be drawn between these two curves. And I can simply add this line to our set as well. So this becomes a compound geometry. And what I want to do is also show you the mirror and rotation transformation options. So basically, I want to set a plane of mirroring on this point. One way to do that would be to set up, to define the plane that we want to mirror. So if you want it to be perpendicular to the end of this point, that plane could be XZ plane. So I can set it up to be XZ plane. And we can set it to be on this point. And since our curve is joint, we can also do mirror here. So I want to mirror this geometry using this plane. And you can see that our curves are now self-intersecting because it's mirroring on itself. A second thing we could do is change this plane. For instance, we could also do, we can try YZ plane. YZ plane. So let's combine it here. Let's look at this one. This also intersects along this direction. Let's see, XC we tried. XY would also make it go up. I think the best one is XC in this case. But to prevent the overlap, we can actually rotate the second geometry using this plane. So if you do rotate, we can use rotate an object in a plane. So I want to rotate the mirrored copy. And if you look at the inputs, it takes in a geometry, angle of rotation, and a rotation plane. So the angle of rotation is in radians, but we could also change it to be degrees. If you right click there and turn it to be degrees, now I can set kind of 90-degree angle of rotation, and we can set the plane of rotation as well. So now this geometry is rotated using that plane 90 degrees. So I can hide the mirrored preview, and we have this plane here where we took the first mirrored the geometry and then we rotated it using that plane. Now we have built a more complex shape, and we can keep repeating these operations. So I can find this endpoint here. For instance, let's say we want to join these two, or I can take this geometry and do find its endpoints. And let's say we want to mirror this time in the XY plane. So I can set up an XY plane at the end of that curve. It's actually giving me the first line. Let's do it to the end of the line. And I grab this curve and let's do a mirror of it. So this geometry, we want to mirror it like this, and we can have another shape drawn like that. If I joined these two before the mirroring operation, then the geometry would have mirrored as well. So for instance, if I bring the join curve here, grab this curve and hold shift and bring it here, and if we mirror this one, you can see that we can build more complex relationships this way as well. So basically that's the essence of kind of building complex shapes. And the cool thing is you can actually change any of these parameters, and you can see that the full shape is changing because we are maintaining our parametric relationships, right? So I can change the arc properties here. I can change the rounding properties. I can change the initial vector locations, point locations. I can make these curves somehow closer to each other. Let me see if we can add one more thing to this. I think this is fine. So we have the mirrored copy. We have the joint curve here as well. So let's do a final join. I'm simply doing copy paste. So I'm going to move this all the way to the end. So I'm going to join these two and draw a pipe. So if you do a pipe, we take in the curve and the radius. So pipe radius could be, let's say, all the way up to 5. We can make it rounded values and reduce the degrees so we can draw a pipe. Now, if we change the rotation here, you can see that the if the angle changes, then the geometry also changes. Now, if you want to eliminate these types of sharp corners, what you could do is simply, if you set it to 45, for instance, then you can go all the way here. After we joined, we can also do another fillet here, right? So if you can fillet the sharp corners of a curve, set up another radius value here, and let's see, this one, it's a single curve. We can actually set it to be a floating value again, and you can control the rounding of that line over there and then use this to pipe. Right, so you can create polylines, you can create any type of geometry, different types of rotation planes, build compound shapes, and then join them, fillet them, mirror them as well. So you can do a lot of parametric variations using these sorts of simple transformations. And if you go back in the script to the earlier cases, if you change any of these parameters, you would see that the geometry is changing altogether, right? So if at any point something is not behaving like it should, you can go back to the corresponding parameter and change its thresholds or values, and you can basically adjust the numeric values. So let's see if I can change, for instance, the arcs here. I can change the z vector here. I'm also trying to make it not self-intersect, but that's essentially the shape that we have ended up with. So one last thing maybe we could do is take this shape and do a YZ mirror as well. So let's see what's going to happen. So I have this one. I could do and points. So find the points, find the YZ plane. Actually, for YZ, we probably don't need it because it's already sitting on the coordinate system. So we could do mirror. You want to take a mirror of this on the plane. So it's kind of a self-intersecting loop. And we can join them before we pipe them, or you can do them separately as well. So you can input this guy here as well. So both of them could be piped. And if you want to create this geometry into a Rhino, you can right click here and bake it. So any geometry you want to output to Rhino, you need to bake from Grasshopper. So if you right click here and bake, you can also bake the curves, for instance. This is the mirrored curve. So any geometry, if I want to create it, we can use bake, but that will be disconnected from the script. So you need to do it as the final operation. And that's essentially what we have created. So this is kind of a parametric loop on its own. It's using mirror reflections, rotations, points, arcs, and lines. And you can basically play around with these sorts of thresholds. So I want to create this simple exercise where you can play with some of the fundamental geometries of lines, arches, and points, and learn about plane orientations and vectors. And if you have any questions, you can write comments below. And see you next week with another video. And thanks for watching.